Our next learning target in this unit is going to be talking about the substitution method. So the last learning target we did was the graphing method. Well, now we're going to talk about a new way to solve systems using a method called substitution. This is a little bit more algebra heavy, not a whole lot of graphing, so make sure you're paying attention to signs, your x's, your y's, because it is a little bit of work for this one. Okay, so first of all, let's talk about the word substitution. So what does it mean to make a substitution? And that means in general. If I'm cooking, I could substitute margarine for butter, maybe some oat milk for regular milk. Those are substitutions, right? So in general, a substitution is to replace something by something else of equal value. So that's the general idea of substitution. You're just replacing one thing that has the same value. Okay, so for example A, I'm going to try and solve this using substitution eventually. The first thing I'm going to do is sorry, let me back up. So let's take a look at this system here. So I've got my first equation is just y equals 2, and my second equation is x plus y equals 6. So this one's kind of nice because I've already got y equal to a whole number. Well, if I know that y is equal to 2, and sometimes colors help with this. I'll get some markers here. Sometimes colors help us differentiate what we're talking about. So if I know that y equals 2, then I can plug it in to the y in the other equation. Okay, so instead of x plus y equals 6, I'd get x plus 2 equals 6. So I'm replacing that y with 2, I'm substituting it. Okay, now I've just got x over here, so I can start to solve this. I can subtract the 2 on both sides and get x equals 4. So my solution then is x is 4, and I already know that y was 2. Okay. Now let's take that same system and solve it graphically. Okay, so let's graph each of these lines onto my grid and see if they intersect at 4, 2. They should. So y equals 2 is going to be that horizontal line that goes through the grid here. So that's just y equals 2. We've done a lot of those. Okay, this other equation I'm going to rewrite. I'm going to rewrite the x plus y equals 6 because to graph this, I need to get it into y equals mx plus b. So I'm going to subtract the x on both sides, and I get y equals negative x plus 6. Okay, and I'm going to graph that in purple here. Okay, so I'm going to start at 6, which actually is, I have to extend this graph a little bit actually. So there's 6 on my grid, way up there. Okay, and my slope is negative 1 because it's an invisible 1 over 1 here. So I'm going to go down 1 over 1 and make points and connect my lines. And you'll notice that it does actually intersect at 4, 2. So both methods get me the same result. Okay, substitution method would get me 4 and 2, and my graphing method would get me 4 and 2. So it's kind of cool. Okay, so let's look at some that are a little harder than that, right? I'm not going to give you ones that are always just, here's a number, plug it in. Okay, that was just kind of to show you the concept. In general, what you're going to be seeing is you're going to be seeing equations that have 2 variables in both equations. Okay, so here's example B. Y equals 4x and 5x plus 2y equals 39. Now over here in your notes, I've given you some step-by-steps to kind of give you a reminder for what to do. Okay, and so we're going to go through these steps each time we solve. Now number 1, the steps should already be done for you generally. Okay, solve for one equation for either x equals or y equals. So I look at my equations. Do I have an x equals or y equals? I do. I have a y equals right here, so step 1 is pretty much done. Okay, you have to get a variable alone in order to substitute. Okay, the next step says substitute that expression from step 1 into the other equation. What I mean by substitute that expression is like I did up top. If I know that y equals 4x, then I can take that expression and plug it into the y in the other equation, okay? Because all of the y's are going to be equal. They're all the same. Y is the same no matter what we do with them. So what this is going to look like is I'm going to have 5x plus, and I'm going to keep the 2. The 2 doesn't get replaced, just the y. But when I replace it, I've got to use parentheses. So it's going to be 2 parentheses, and instead of y, I'm putting in 4x. And then I'm going to continue with the equation equals 39. I've replaced y with 4x because they're equal. They're equivalent. I can do this. Now I've got an equation just like back in Unit 2 that we solved, and we have to remember how to solve these equations. So I'm going to draw my line that helps me, and I'm going to start to simplify. I'm going to keep this 5x. 2 times 4x gives me 8x. I noticed that 5x and 8x are like terms, and that would combine into 13x. And then to get the 13 away from the x, that's division. And 39 divided by 13 is 3. Okay, so now I have my x value of my coordinate. So that's my first piece of the puzzle. However, in order to solve a system, I have to have an x and a y. So I have to have a full coordinate. I have to figure out what the missing y is. In order to do that, we do step number 4. So I just did step 3. Solve the new equation and get an x or a y equals a value, which I did. I got 3. The last step then, plug that value into one of the original equations and solve for the other variable. So if I know that x equals 3 and I don't know y, I'm going to look at this first equation up here, y equals 4x. I'm going to rewrite him over here in some blank space. But now that I know that x is 3, I can write y equals 4 times 3 because I've just figured that out. And voila, now I know that y is going to be 12 because 4 times 3 is 12. So that's my solution, 3, 12. Okay. Systems always have 2 solutions. Always have, as a coordinate pair, will always have an x equals and a y equals for every answer. Okay. Let's take a look at a couple more examples here. Okay. Scroll up here. All right, so example C. Solve using substitution. So now I've got 2 equations where they both start with y equals. Those are kind of nice because really what you're going to do is, you do the same thing. You're going to take whatever y is equal to. So in this top one, it's equal to x plus 10, and you're going to replace it in the other y. So on the left side, I've got y on the second equation, but instead of y, I'm going to write x plus 10, and then I'm going to carry down that 4x plus 19. So instead of y equals 4x plus 19, I get x plus 10 equals 4x plus 19. I've eliminated up 2 variables, so now I can go ahead and solve this like we did again in Unit 2. So I'm going to get my x's on the left. Those cancel. I get negative 3x plus 10 equals 19. Subtract the 10 on both sides. Negative 3x equals 9. Divide both sides by the negative 3. And I get x equals negative 3. You've got to be really careful with your signs here. Pay close attention to how you're solving. All of that stuff is going to make a difference. Now I've got the 3, so I know my first part of my coordinate pair is negative 3, but now I have to find my y. So I'm going to pick the top equation. It doesn't matter which equation you pick. You could pick either one. I typically tend the top one because it's just there first. Rewrite it. Okay, but now that I know x is negative 3, I can write y equals negative 3 plus 10. I'm replacing the x with the negative 3. And now I can do that arithmetic. Negative 3 plus 10 is 7. So I know my coordinate is now negative 3, 7. Okay. We'll do a few more here together. Okay. So example D. This one looks a little scarier. All this one really is going to mean is we have to do a little bit more algebra, okay, because there's just a lot more values and numbers here, okay? So we look for the y equals or the x equals, either one. In this case, it's our second equation. So here I know that y equals this thing, 8x plus 24. So I'm going to take that and I'm going to plug it into the y in the other equation. So instead of the top equation being negative 7x minus 7y, I'm going to put negative 7 parentheses, and I'm going to replace that with 8x plus 24. Okay. Now this one's going to require just a little bit more steps to solve, but the math, the concept is no different. All the steps are the same. You're substituting in an expression, and then you're solving algebraically. So for the first step here, we always have to distribute. So I'm going to drop down that negative 7x. 7 times 8 is 56. Negative 7 times 24. I'm going to get my calculator out for that one. Negative 7 times 24, that's negative 168 equals 21. Now I'm going to look for like terms. I notice that these two are like terms, negative 7 and negative 56. When I put that into my calculator, negative 7 minus 56, I get negative 63. So this becomes negative 63x minus 168. And then I've got to add the 168 over. And I get negative 63x equals 189. And I'm hoping this works out evenly. Our next step is to then divide by the negative 63. So let's put that in our calculator. 189 divided by negative 63 gives me negative 3. Cool. Okay, so my x is negative 3. Notice that this requires a lot of work we've done in Unit 2. Okay, it takes us back from a long time ago, but all of this is stuff we've done before. All of this solving, combining like terms, using the distributive property, all that stuff is stuff we've done before. You just have to be very careful and pay close attention to detail here. Okay. So now that I've gotten my x, that's my first half of my answer in my coordinate pair, but I still have to find my y. And in this case, I'm going to pick the second equation because this first equation has y kind of jammed in the middle here, but in the second one, y is off to the side and it's by itself. So that's going to be way easier to solve for. So I'm going to rewrite that second equation. Again, it doesn't matter. If you pick the top one, you'll still get the same answer. It's just going to require a little bit more math. Okay. So I'm going to rewrite that second equation, but now instead of x being here, what do I know x is? Negative 3. So I'm going to replace the x with negative 3 and plug it in. So I'm going to have y equals negative 24 plus 24, which is 0. So my answer to this problem is negative 3, 0. Okay. So again, concept's the same. You're substituting in an expression for a variable in a different equation, solving for one of those variables, and then replugging that value in for the other. Okay. So now we've got two situations to talk about though, because there's going to be, we talked about this in the first learning target about, well, what happens with systems that have no solution or infinite solution, because those are going to pop up. What do they look like, and can we solve them using this method? Graphing method, remember, infinite solutions was just like one line on top of it itself, and no solutions were two parallel lines. So what does that look like in a substitution method? So let's take a look. So for example 1, we're going to solve using substitution first. So I'm going to take my first equation here and plug it into the y in the other side. So I'm going to get negative 2x minus 4 equals negative 2x plus 1. When I set this up, I'm taking the negative 2x minus 4 and I'm plugging it into the y in the other equation, which gets me an equation that looks like this. So we're going to solve it. I'm going to add my 2x over to the other side. And what happens is these both cancel out. Negative 2 plus 2 is 0. Negative 2 plus 2 is 0. They're both gone. So I end up getting negative 4 equals 1. And if we remember from Unit 2, what happens when I have two numbers that are equal, but or say they're equal, but they're actually not? We would write no solution. We'd learned this a few months ago, right? So this is what it looks like when you're using substitution method. You're going to get a weird false statement at the end of your problem, okay? If I want to graph this now, let's graph the first equation here, the blue one. That's going to start at -4, and I'm going to go up 2 over 1. I'll make some points here. Okay, so there's my blue line. Let's make the second line purple here. So that's this line. That's starting at 1, and it's also going down 2 over 1. And what do we know about lines that have the same slope? They're parallel, and what do we know about parallel lines? They never intersect, so they'll never have a solution if they're a system. So these algebraically it looks like this, graphically a no solution looks like this. Okay. What about something that has infinite solutions? That's example F here. So if something has infinite solutions, let's solve it algebraically, see what that looks like. So I'm going to take the 2x minus 1 and I'm going to plug it into y in the other equation. So I'll have -2x and then plus, instead of y, I'm going to write 2x minus 1 equals -1. And now I'm going to look for like terms. -2x and 2x are like terms. Well, what's -2 plus 2? 0. So I can just cross those off. They're 0. And I end up getting -1 equals -1. And hopefully that kind of rings a bell. Oh, if I have two numbers that are the same on both sides and all my variables are gone, that's basically infinite solutions or all real solutions. Okay, so that's what that looks like algebraically here. If I were to graph this, let's make this first line the blue one. I get -1 is my starting point, and my slope is 2. So I'm going to go up 2 over 1. So there's my first line. Now my second line is trickier. The second line is not in y equals mx plus b form. I can't get my slope and my intercept right away. I'm going to rewrite it down here. I'm going to rewrite -2x plus y equals -1. And I'm going to go ahead and solve for y, like we did in that matching activity. So I'm going to add the 2x over, and I get y equals 2x minus 1. So I'm going to graph that one, and you'll notice that 2x minus 1, they're the same equation. You should notice that. They're the exact same, so they're going to go over each other. The purple line will just go over the blue line. And when the two lines go over each other like that, that basically is telling you, oh, they're the same line, therefore it's infinite or all real solutions. Okay. So those are the core ideas of substitution method. It's a lot. It's a lot of algebra work. It's a lot of being careful with signs, being careful with parentheses, plugging things in correctly. But once you do a few, it does start to kind of become habit. It just takes practice. Okay, good luck. Let me know if you need help.